Diveflyfish. Just want to show you something. Here are my two tackle box cells. I'm going to show you something somewhat interesting. These are both hard as a rock. They're putting out about 7 milliamps current and hooked in series, but I have to let you know that later on I'll show you another video where I have this tiny little cell here that puts out exactly the same amount as this with about 10 times the surface area of metals on the inside. So I do believe that it's more dependent upon the nature of the crystals. Now I just want to show you another phenomenon. You know, these two batteries are separate. Obviously I have not connected these two electrodes, and if you notice the voltage, if I take a little copper wire and just bridge it across the electrolyte, you'll see it registers the voltage. Okay, so the electrolyte itself bridges it as to be expected with the copper wire. Okay, so getting just about a volt there. Now what I'm going to do is I'm going to take a little bit of this material here and I'm going to sprinkle it right in between these two batteries here. Okay. Again, that's just some more of the dried material, just to give you an example of the exquisite transfer potential of energy between those two cells, even with the dried crystals. So again, that little sprinkling of dried crystals is pretty impressive as far as what it's able to do. Thought you might find that interesting, and I'll show you more tests later. But I do believe Lidmotor is correct. It is the nature of the chemistry that's going on here that is of infinite interest, more so than I think the electrode size, for what it's worth. Oh, this just hit me right now. It's probably worthwhile seeing what type of current that little bridge can produce. Okay, so without moving the electrodes, I'm going to just take this off the meter and put it in the milliamp hour range, or I should say in the current level. Shut this off for a second so that we can use this as a surprise. I set this to the 200 milliamp level. And again, the only thing that's connecting those two cells is that little pile of dry electrolyte. Okay? So let's turn the power on and see what kind of current level we're getting across these cells. Lo and behold, we're at about 6 milliamps, which is roughly what the normal cell would produce by its lonesome. Okay? So the conductivity of that crystalline substance is phenomenal. So what I'm going to do now, just to show you, is I'm going to take off this electrode here, and I'm going to brush this material aside. Oh, no, I just made more of a mess, but try not to have any crossing electrode bridges. Double check it. Shouldn't. It's not making anything now, so I think I remove the conductivity there. It's back down to 0. Okay. So there's no bridge there anymore. So now we'll just check the current level on one battery. And there it is, the same. So even having a little dusting of crystalline material, I really think that overall the amount of surface area for metal is less than needs to be. And I go back to my original experiment that I saw with the oxide layer. I think there's more potential to be seen here on a microscopic level than on a macroscopic level. I could be wrong, but that's what these tests seem to be indicating. Okay, so that's that one. Again, the same amount of current passing through the direct interface of these electrodes as through that small crystalline dust bridge that I just made. Okay guys, some of you wanted to see what that 2-volt cell looked like. Again, this was the the carbon magnesium variant, and again this is producing over 2 volts, 2.04 volts on that little guy right there. Okay, and to give you an example, this has not been touched. And just break this off here. So you can see that's what the crystal interface looks like on the carbon side. And this has been dry. And there you can see below there it's just the oxide layer on the magnesium. And there's no pitting, there's no holes or anything like that. It's just the dry material. Sorry about the lack of being able to focus down on this, but in any event, so again, this is dry. There's no fluid on that whatsoever, alright? And this hasn't been touched since I assembled it until I just broke it right now. And I'll put it back together again, just sort of putting those little fellas back like that, and let's see what the voltage is. And I'll bet you a nickel to my name that it's at the same level that it just was. So here we have carbon and the magnesium, it's still 2.05 volts, okay? And for grins, check to see what the current level is. So about 7.8 milliamps, okay? So again, it's not about surface area. I think it's about the nature of the constituent crystalline mix, and I think the difference in output has to do more with the ratios of the zinc oxide versus the Epsom salts and titanium dioxide, etc. So tweaking and changing that a little bit, I think, has more an effect on the current level output. So there's that 2-volt cell. All right, and I'll show you more in just a second. This is sort of an interesting one too. This is really, really thin. This is just some extra spillover, and again, this hasn't been touched. This is just maybe a 1/16 of an inch that I utilized, and this was the reconstituted stuff, and this is over a week old, and it's dry, and it's actually held together pretty firm. Now, this is the interesting thing. Now what we'll do is we'll measure the voltage. Sit down here, so put it on 2-volt range, okay? And here we have a reading, okay? It reads just very nominal, okay? Now what I'm going to do is I'm just going to breathe on that and watch where the voltage goes, okay? The voltage jumps just by breathing on it. Try this again, hang on. Now it should work. It's hard to breathe from that far. Yeah, 1.5. So in any event, you just have to breathe a little harder. I guess we can't do it from a distance, but that's how sensitive, exquisitely sensitive, those cells are to any form of ion moisture. And again, you're seeing it dissipate very quickly because there wasn't a lot of moisture around to act as ion carriers. And again, it's drying out remarkably fast, but this is seemingly what happens. So in the absence of any form of fluid, I don't believe positive ions can be mobilized. And the issue is there's a much larger surface area, I think, on something like this that just picks up enough ambient moisture from the air to keep it running. And again, that's all that was in there. And we can see what the current level is here on this battery that wasn't registering much of anything. And usually the current level is always higher than what the voltage registers. So if we're reading this, it's going down. It's still there. So if this were a little bit more moist, I think you'd see that current level jump up a bit, but still the current stays ahead of the voltage based upon my experience with these cells. There's the 2-volt mark again. Yeah, so in any event, it's interesting, that phenomenon unto itself. And this is that Oreo cell, the original Oreo cell that I made. Again, it's been dry. Not doing a darn thing, really. And again, we can check the voltage on it. What you see there, let me actually turn it to the millivolt range, because I think it was last time I checked it was like 200 millivolts. find the right thing? Wait. Get a little bit of moisture there. Yeah, there we go. So you see her climb just with a little bit of, it takes an infinitely small amount of moisture just to get that stupid thing to start going. But again, that's how sensitive they are. Okay guys, this cell was a calcium carbonate addition to the mix, and I used glycerin as the reconstituting liquid. And again, you'll see what the voltage is here in a second. Alright, so here is the cell, let's lay it right there, and there is the voltage, 1.88. Okay, fair enough. And again, this obviously is still moist because we used glycerin. Now, let's look at the current level for that just for grins. So the current level here, probably around 6 or 7. Okay, 6.9 to 7, something like that, maybe a little less. It's stabilized. Okay, so high 6s. Now this is the other interesting fact. This tiny little cell I just made a while ago, not too long ago maybe. But I again used the electrolysis method to create the oxide layer. And again, this is 1/5 the size of this cell, okay? And probably 1/10 the size of those cells as far as the overall surface area. The thing covered by the blue PFT tape is where the overlap is between the magnesium and the copper. So it's about a centimeter square. And when you look here, you'll see what the current level is out of this little guy. Let's see if I can get a better view here. Try this side here. So 6.2456. So I mean it's 6. We're getting 6.5 milliamps out of that same thing, out of what we're getting out of this battery here. So again, I believe it's chemistry, like lid motor said, more than surface area. Whereas with a galvanic cell, you'd have surface area affecting it more. And these are not galvanic cells, in my estimation. Again, there's 10 times the surface area on that large cell back there. All of these things being equal. So you can still produce current with a lot less area. So for what it's worth, and again, just to show you for grins, this cell definitely works, but it doesn't take much. Doesn't take this much material, I think, at all. So there you have it.